So where you can apply this linked list, I told you, in your web page itself. But nowadays we have seen so many web pages which is normally having a using doubly linked list only, doubly as well as circular also, because we have both previous and next page we can access. But only in very few pre olden web pages, or you could see only the it will go to the next page, and it will not be reversed back to the previous pages. That cases linked list actually was used. So now one of the applications which we are going to learn is your polynomial arithmetic also. So how the arithmetic calculations are done. So normally your applications of linked list will be, you can use the same linked list actually you will be using for implementing in stack and queue also. Stack and queue, then you will be studying third unit stack and queue, then you will study the same thing in fifth unit also, graph. In that also you will be using this linked list. Then normally the dynamic memory allocation only is performed here. Then if any names to be maintained by like a sub list, so that can be maintained. Then in arithmetic operations, then in polynomial, that only we are going to see it now. And even in sparse matrix also, I told you. In sparse matrix, the previous classes when we saw, I told you in sparse matrix, we need a row index and a column index followed by a non-zero value. So this was like array. In array, we had 3 rows. That is your row. We had only 3 columns. One will be taking out the row position, one will be taking out the column position, and one will be taking out the value of the that is non-zero values. But in your, with the same thing, when we represented using linked list, I think hope you remember it. When we represented using linked list, we had four. Like normally a linked list will be having a data, and that is a value and the address of the next particular element which is being pointed. But in sparse matrix, we had a row index, a column index, then the value, then the address of the next value where it is pointed. So we were using a sparse matrix for denoting by using linked list also. But we had 4 fields in it, row, column, and list. Similarly, for using this polynomials, you know that what is a polynomial. You need a coefficient and the power. Okay, that is the most important thing in polynomial. So you can see it over here. You see an example. A is equal to 3x power 14 plus 2x power 8 plus 1. So 3 is your coefficient, then your exponent, then you will be having the next ones, maybe where this next element is being stored, that address is over here. In sparse matrix, we had 4 fields. 4 fields, as I told you, you know what it is. But here for us, only coefficient and exponent is more important. And what is that? Where is the next one stored? That address. So this is normal process. So these together we will be considering it as value. Now you see here struct link. We have coefficient is an integer value, power is an integer value, and the next is the address where we are going to get the next elements where it is stored at. So here there are 2 polynomials. So here A is 3x power 14, 2x power 8 plus 1. So A will be 3, that is coefficient is stored here. Next is your power, then next address where this is stored. 2, 8, and next we have one more element. So 1, but no power, x power 0, that is no power, and there are no more elements here, so it is null. Similarly, when I take it B into consideration, x 14, 8 and 14, then minus 3 and 10, then again 10 and then 6, then finally it is null. So this is how the representation is. So how you are going to perform by code, or else an example also I'll show you. So these are the normal terms which we are going to use. You have to the exponents of, about the calculation of the polynomials. If both these terms, exponent terms are equal, you can add it. Otherwise, you cannot do it, right? You will be switching on to, you will keep the you will keep the term as it is, and you will go to the next higher order. So this is what. So the initial checking is your exponent term has to be checked. That is the main thing. So you have to check A for the particular A. A is variable. We are using a pointer. One pointer will be moving out like this, and another one pointer will be moving for B. So that both will check the exponent only first. If both the exponents are equal, then it can perform the addition operation or subtraction or whatever it is. If it is not equal, it has to just copy out the same thing as it is. So that's what is explained over here. So I'll show it by means of diagram. You see here 3, 14, 2, 8, 1, 0. Similarly, the same same thing. 8, 14, minus 3, 10, and this. So first your pointer is in A. That is, it is in this exponent field, pointing to the exponent field. Then here the pointer is in B. Now both will be compared. A's exponent is equal to B's exponent, means both can be added up. So I have added and I will store it in a separate variable that I can call it as D or somewhere D. Okay, D. Okay. So here it is mentioned. So now 3 is 14, 3, and 14's exponent 8. So 8 and 3 will be added. 11, exponent is 14. It is stored in a variable D. Now my pointer A will move to next. Poly, maybe A is next, A of next. So it will now come over here. And this also is being traversed. So B of next. So it will come over here. Now again A's exponent and B's exponent will be compared. So now you can see B's exponent is greater than, because A is only 8 and B is only 10. Are you getting it, ma'am? Students, are you getting? Yeah. So A's exponent is 8 and B's exponent is 10. So now what happens is this both is compared and this is greater, this is lesser. So when this is greater, the greater ones only will be copied to the D, to another variable D. So this will be taken out here. And this pointer will move now, but this pointer, A pointer, will remain the same in 2 itself, that is in 8, coefficient 8 itself. B's pointer alone will be, because B has been copied to the third thing. So B's pointer will move to the next. So B's, what sound is it? So B pointer will move to the next term now. So now this will move to now 6 over here. Now what happens? This 6 and this 8 will be compared. Now when A and B's pointer are compared, it is found that A's coefficient is greater. So now this will be displayed in D. Now this pointer remains as such because it is not being taken out to the result value. So now this will move over here. Now this and this will be compared. Now this will be taking the same value here, and finally this will be displayed. So this is what your result will be. First the coefficients will be compared. If it is equal, addition is performed. If not equal, it will, that is the which is greatest value will be printed out and the pointer will be moved. But one which is the previous one will be as such as it is. So when coming,
ma'am, but the third function, it's not written.
Which one, ma?
The third one, ma'am.
Yeah, this one also will
That 1 0 null and 10 6 null.
Yeah, here I have not displayed it, but it will come. All the answers has to come. In this diagram, I have left it out. Okay. So it will come.
And so here we need the list in decreasing order of
What, ma'am?
exponents.
Yeah, yes, it should be in the same order, like 14. Then like your answer will be 11 x power 14. That is 11 14. Then minus 3 10. Then 2 8 should come. 2 8. Then 10 6. Then 1 0 will come.
Ma'am, I mean the polynomials which we are adding, they should be arranged in the decreasing order of exponents, right? For this.
Yes, yes, yes. 11 x power 14 minus 3 x power 10 plus 2 x power 8 plus 10 x power 6 plus 1 plus 1. Okay. So when I'll show you the code now. So how to create polynomial creation? In create, as you create in linked list only. You are getting the coefficient, then you are getting the power, everything. Then you are, for each node you have to create the malloc procedure, the same thing. Then always you have to point out. First time we do not know, first node will be always having a null value. So after that, when the node gets added up only, your link will be formed. So until then it is null. If it is S, then again keep on getting the node. This is just for first initially getting the input, and this is just for displaying. If your node is not null, only the name, variable name is changed. Other thing exactly like your singly linked list only. So until the next node, last node is null, you keep on traversing. See here, these all are displaying procedure. To display it x power, I have given like that. We have given x power value, which should be displayed. Then it takes the coefficient. This will take the coefficient x power, then the power will go there. Okay. And if you want, that is, it will show. So here, if node of next, if you have still have so many number of coefficients, that is, or values, it will go to the next value until if node not next is equal to null this. So finally your output will be like this. You will be having like this. Your output will be 11 x power 14 plus here it is minus. So minus 3, 10 x power. You will have an x in the middle, x power. Then again plus. So for that only we are adding this plus all. So we're displaying. How to display? The displaying can be designed as per our needs. Okay. Now see this procedure. Polynomial add procedure. Just as I told you with the diagrammatic explanation. You are having there, I showed it as A and B. Here I have given us poly 1 and poly 2. Then your storing result will be in poly. That's all. So while poly 1 of next and poly 2 of next, that means you have two. You have you are having both the two variables. That is, you are having in poly 1 is also having some values, poly 2 is also having some values. If both are having the values, you have to proceed this only. If one variable is there and one is not there, you will be taking this part. Okay, now we'll take this. So if poly 1 of next and poly 2 of next true. So when it is true, you will be coming here. If poly 1's power is greater than poly 2's power. If poly 1, that means your first expression is having a greater power than your second expression power. Then copy the first expression into your result. Your result I have named as poly. The other two expressions are poly 1 and poly 2. Result is poly. So poly of power is equal to that, which is having the highest power, that will be copied to your poly. Now similarly, that particular coefficient is also copied to the particular poly result. Result is poly. That's what. Then it is moving. Now the poly 1 is moving to the next the expression. The first expression is moving to your poly 2. Then expression 2 is having the higher power. You know that expression 2's coefficient power has to be copied. Expression 2's coefficient has to be copied, and expressions 2 will be, now this it will move to the second variable. Now both are false. In case your poly 1 is not having a greater power, poly 2 is also not having the greater power, means both are equal. That's the meaning. So in that case, what you have to do is, you will be copying any one's expression to poly. Means both are having the same power value only. So you can copy the any one here. So here we are taking as default poly 1 itself to the result, and then the next one is, if both are equal, you know that in a polynomial, if both are equal, you have to add it up. Poly 1s and poly 2 has to be added up and stored here in coefficient. Now since both are added up, you have to move to the next variable in poly 1 also and in poly 2 also. Okay, so this is the procedure which is followed over here. So for poly also you need to create, because poly is a new result link, right? So you have to memory allocate for poly also. As you create for poly 1 and poly 2, you have to memory allocate for poly also, for the result also. That is another time up.
Yes, ma'am. In
5
2 minutes, you
minutes.
have to join the other class, ma'am.
I have told him actually, this hour normally I'll take some 5 to 10 minutes. So I'll leave with this, I'll end, because otherwise again it will be only one slide is there. That's
Okay,
all.
ma'am. Okay, ma'am.
Okay.
Yes, ma'am.
That's okay. So you are moving to the next one. If it is both are there. In case if only one is there, that is I told you know only one of the particular expression is having a higher degree and one is not having a higher degree means, then you will be copying only poly 1's coefficient power in the result variable, or else if this is not true, then you will be copying only poly 2's expression power and the coefficient value. This is applicable if both are not having equal number of terms. If one is having higher term and one is having lower term, this will be applicable.